into your data to provide you a real picture of your reliability, I think is important as a consumer of that technology. It's what we are. Gordon is a data company, right? We're selling data to our customer, and we provide data, and we use that data. So I guess is what I was getting at with that.
No, it makes perfect sense, right? Once again, going kind of back to the tech industry, it's been interesting watching SpaceX, right? And it's funny, for the longest time, no one's really seriously tried to pursue this just yet, but like the questions come up a lot of like, man, it is so hard to keep an NWD reliable run after run after run, and it's still even hard today to predict like when it's going to fail and really achieve that ultimate reliability of never failing. It'd be nice as if we could just have disposable tools. It's a run one tool, they're all brand new, they go in there and they run and they're cost effective enough to just throw them away, right?
Right.
It's funny because you look at the rocket guys, and the rocket guys are going, gee whiz, it sure would be nice to use this thing again, right? We have a lot of cost in here, right? And I think there's a ton that we in the NWD industry can learn from SpaceX. One is they've been able to attain reliability with a lot less expenditure on R&D than others have in the past, right? And so, NASA would, like, for instance, the hatch on the capsule, right? To really understand the reliability of that thing, back in the day, they'd build 10 capsules and they'd drop them out of airplanes in the concrete, and they'd submerge them, and they'd fire the explosives 1,000 times and make sure that the hatch opened all 1,000 times and all this kind of stuff. And like pretty much to map out the reliability curves and understand, all this device was going to do over time. Like they really just built tons of prototypes and put them through every scenario they could imagine and studied it, right? Which is, as kind of being in the hardware business, it's extremely expensive.
Yes.
It's extremely expensive. It's shockingly expensive. It's government level expensive. Which was always what has amazed me about NWD so much, because it's almost like we have all the requirements of space, but none of the budget. But SpaceX has been kind of controversial because they've been able to kind of achieve that same reliability without building all those physical prototypes, right? They've been able to use different types of statistical modeling, et cetera, to make a bunch of really educated assumptions about how a component is going to perform. And so far, it's worked out pretty well for them, right? Mm-hmm. Additionally, they almost have a higher standard of reliability than we do, even because it's if you have a bad couple runs, you might lose a job, right? And that's horrible. Like, that's really rough for your company, but you've got a chance to get back, right? If SpaceX blows up 4 astronauts with a Falcon 9 on the launch pad, all their techniques and everything else going to come into question. It might just kill the company. They might just be done. Yeah. Even with everything that they've achieved to date. It's interesting looking at the reusability of the rockets. I've just got to think that there's got to be some sort of inspection or statistical techniques for reuse that they're looking at that could be applied to NWD tools and give us a lot of oomph behind what we do and how we manage stuff, right?
Yeah.
Yeah, I'm sure you have to track the structure of the rockets and look for tiny little cracks like you do with aircraft. You have to inspect them periodically and look for fatigue in the aluminum and all that.
Right. Well, I wonder though, which way's better? So if we're talking about disposability of tools, if you can make PCBs cheap enough to the end user to where they can dispose of a board after so many runs, just because the new ones are so cheap. You take a board and it's got, maybe it's $400 or whatever else, and they pay $800 for it. That might be cost effective to prevent a failure.
But no, I think you're right. I think the circuit board level is probably the most candidate for considering a disposable phase, right? Especially as we try to push to higher and higher temperatures, right? Which is a huge talking point right now. How do I operate at 200 degrees Celsius, right? Which is really non-trivial, right? Going from 175 C, which I guess has kind of been the bar of the industry of high temp for a long time, to 185 C or 200 degrees Celsius is very aggressive, right? And so, especially at a circuit board level, and the electronics are one of the hardest things to get right. I mean, I think it's going to be much more practical to potentially have a disposable approach, like a 1-run, 2-run approach to electronics, versus trying to make electronics that, is going to survive for 500 or 1,000 hours at 185 or 200 degrees Celsius, and take the time and build enough prototypes to explore all the wonderful ways that solder likes to chemically react with everything around it for 2,000 hours at 200 degrees Celsius, right? No, thank you. And so I think you're dead on, right? So maybe we don't get to full tool disposability to where the entirety of the thing gets chunked, right? But portions of it for the right job.
Yeah, and then you just consider the financial part of it. This board cost X, and we get a payback on it after 3 runs. Maybe it's a 3-run board. So there's limited disposability too. There's not a 1 run, but maybe it's 3 runs, and so if you find that payback and you just avoid the failure, but then you never do find the weak point, do you?
Well, I mean, but that's not true, because you could always start with disposability, use that to attain a new level of performance that you can't get now, and then continue to push that bar, right? Because if you can get those units back and study them, what you could do is, let's say you make a 1-run circuit board, right? And you go and you run 10 of those or 20 of those, right? And you get your value out of them in a hot hole, right? Then bring all 20 of those back, put them in the halt chamber, and precipitate them to failure in a safe environment, which is the lab. Look at what breaks, fix it, rev the board, do it again, and just keep pushing forward, right? That could be incredibly interesting, right? So it's that's been one of the things that's been hardest to kind of close the loop on, right? Because it's like, okay, well, we researched and developed the asset, we produced the asset, someone bought the asset, they went and drilled on it and got a long life out of it. It's done, man. We don't have time to go back and after action review this thing and take it to precipitate it all the way to failure and keep studying it. Like, that may be a level of lacking discipline that can really, really make a big difference in this industry, right? So, anyways, go ahead, Dave. Go ahead.
Yeah, Hunter, you had mentioned kind of before we started the podcast, kind of talking about the transition from a sole contributor to more of a management role. Can you tell us a little bit about how that's been for you and what are kind of some of the challenges with that?
Sure. Yeah. In 2017, I came into a team where we had my manager, Ben Frith, and another engineer with me and or alongside me. And in a few years, there's now there's a little bit of a team and manager type aspect for my role, where I'm looking at a team of 4 or 5 engineers below me, and trying to manage them out. And I was telling Ken that it's been a difficult transition for me to relinquish control of some of these aspects of projects or R&D that I need done, but maybe my own pride limits me from either training them to do the job that I need them to do, or letting them go with it and learn from their mistakes, right? Typically, not to say that I'm some sort of great designer, but in almost anything where you feel like you've got a leg up on a task or a project, you might say to yourself, it would take more time to train someone to do the job that I can do. But the fact is, you'll never do it because you don't have time in the first place. You have time neither to do it nor to train them. So who's going to do the job? But really, you have time to train them, because if you train them, then you're just that much more productive as a team. So it's a difficult transition to go from being a solo type engineer or having that all on your shoulders, and then you get well, let me just say this. You guys probably know this. As an engineer, as someone who solves problems for a living, when you display that you can solve problems, you're never without problems. And so, that it goes across the organization, and pretty soon you've got many hats to wear.
Well, let's just be honest, though, because pretty much all of business life can be boiled down to solving problems of one nature or the other, right?
Well, from my point of view, it comes from an engineering aspect, and but I agree with you. It's broader than that. But so that's, you end up getting handed a lot of hats to put on and wear, and pretty soon your day's filled up, and the thing that you thought was your base kind of task to do becomes secondary or tertiary, and you've got to find a way to hand it off. And if you haven't, or you haven't prepared yourself to do that, then maybe you haven't done a good job of preparing your team to do that. And that's what I'm kind of realizing.
Yeah, well, what I was always told was if you don't want to do your job anymore, train someone else to do it. And so, maybe if you don't want to solve problems anymore, that's what you should do. But no, I definitely identify with the struggle, and I went through the same thing myself. And I think you asked me, like, how long did it take to get over that? And it was a long time. It was like half a decade, right? Of like, me having to knee jerk back and forth between thinking I could do it all versus delegating to people and all these kind of things. And I'll tell you who I've learned a lot from is Mr. Chris Conger, who's our president and kind of oversees the operations of the company. He's a master at it, right? Like he never thinks for a second about doing something directly himself. He always, even when like it's infuriating and you'd rather just get something done, he's always dedicated to like taking the time and training someone else up. And I'll tell you that was a huge shift for me, because I'm the go-getter. I'm the problem solver. I try to solve everything as fast as possible, design everything as fast as possible, and keep the pace up that way, right? And you can only do that for so long, right? Before things kind of become this unmanageable ball of momentum and it kind of falls apart naturally because you didn't put a bunch of infrastructure in place. But watching Chris work over the last couple of years, the over time, slowing down to speed up has really worked, right? Like taking the time to slow down, invest in people, and then train them up and get them going to the point where we're in the speed up part now, and it's starting to scare the shit out of me because it's going so fast, right? And it's like the roller coaster took so long to get to the top of the hill, and now that it's finally going, oh my God, here we go. And I think this is a really interesting thing to talk about, because I think a lot of people are going to go through this transition in their career, and it's tough. Like it's one of the toughest things to do.
Yeah, it's definitely been really hard for me as well. And one of the things Chris Conger was also telling me about is just the importance of focusing on high leverage activities. I can train somebody once and then, bring them up in that and kind of have them take over, or I can, do it myself. But in the long run, it's like, what is going to bring the most leverage to my time and to the activities that I'm doing for the company?
Well, and I'll say, like, a lot of the things that come up on a daily basis that kind of keep you from, like, quote unquote getting this real stuff done. I mean, those things are kind of in the moment, kind of the problem of the day, right? And like you kind of solve the problem of the day, but that's not really investing into your company per se, right? And like when you can sit down and focus internally on training someone, or when you can sit down and focus on building something internally and not getting interrupted, like making some new invention or product or whatever, those are the things that really make it overall big difference, right?
Right. And let's not poo-poo the idea that you need to take that time to be creative and spend the time doing those tasks, which maybe you have trained someone to do, but it's good for, you can sit back and do a coding project for a month, or even in your off time, because it lets you explore that part of your brain, and you got to do it every once in a while. And so even if I've got a team of engineers who will go and do all the work we give them, and it's going to be fantastic. It's also good to take a break and do some engineering work, do some design work, get back into it, and remember what it's like to model a project, put together, look for the interferences, check your threads, do all the stuff that you have to do anyway. When you're checking drawings, do it yourself. It's important to do that. And I don't want to forget what it's like, but then again, I also don't want to do it that often.
Well, it's funny because, like, I remember reading some stuff about Bill Gates, and I think he went through a very similar thing, and he was kind of complaining of like why everything was getting so complex and slow one day. And it's like, he's like, oh, we wrote the original file system like on the plane, and so he's like, okay, Bill, well then you go ahead and write it. And he's like, oh, okay, that's not going to work anymore. But no, you nailed it. Like I have come to the realization that, like, at least every 18 months, I have to, really most of what I need to be focusing on is, they call me, I get called the internal title, which is very embarrassing to say out loud, is visionary. So I'm supposed to like be talking to people about like the industry and, you know, what next to do on the product and the customers and all that kind of stuff. And that's what I keep getting told is the most valuable way to spend my time, and not necessarily like building something myself. But every 18 months is I have to get in there and roll my sleeves up and build or test or do something to kind of scratch that creative itch. And honestly, I think kind of keep my head grounded in the reality of you know, what's going to work and what's not going to work, right? Because I think that really is a big part of problem solving.
Absolutely.
So, speaking of problems, I think kind of one problem we kind of tackled together was you know, low cost LWD, right? And azimuthal gamma has always been a really sought after and interesting measurement, but it's always had a problem for years that, I mean, it was just too expensive to really go mass market, right? And so I think one of the things that we saw was necessary was to, you know, take that tool, which used to be, I mean, and we actually built one of these things once upon a time. We built like a big 8-foot collar. It had 4 crystals in it and electronics and a short hop back to the probe and everything. And big expensive tool, right, for ASI Gamma, and really miniaturize that, make that cost effective, slash the cost of running it by, I don't know, 80%, you know, 75%, and, you know, get that azimuthal gamma measurement to the point where you could run it on every single NWD, right?
That's right.
And you know, it's funny because I remember talking to everybody in the industry at the time, and I can't tell you how many times I was told that can't be done. You have to go to the collar to get a good image. The gamma ray won't penetrate through the collar to give you enough resolution. You can't put enough shielding in there. It's not going to work. You're not going to get a good image. And I don't think anything can be further from the truth, right? I mean, you absolutely can build a cost-effective tool that gives you a great image and miniaturizes that measurement to the point where we can consider deploying that on every single NWD string now, right?
That's right.
So, and then I you know, the other important thing also to keep in mind is the workflows, right? And getting that data to the surface and geology, et cetera. So, you know, what do you think is like the next measurement we need to look at, right? Is it resistivity? Is it neutron? Is it some sort of sonic? Like, what's the next thing on the chopping block to become kind of miniaturized and made more cost effective?
Well, I don't know about miniaturized, but we are currently working on bringing real-time weight on bit, torque on bit to the market with our acquisition of Maxwell Lodestar. We're going to have capability, and probably within the next quarter, to send up compressed weight on bit, torque on bit, useful data. So, you know, I think the push is there's a two-pronged push, right? And there's always this tension between, or I believe there's tension between the geologists, you know, the petrophysics part of the oil companies, and then there's the drilling engineers who are engineers. They want to do things efficiently and fast, right? There's a lot of data to be gathered. So the azimuthal gamma ray answers the, you know, it scratches that itch for the geologists, the geosteerers, gives them the data they need to stay in zone, stay in target. Great news. You know, the weight on bit, torque on bit gives our engineers bending, gives them tortuosity, gives them the ability to know or acknowledge if they're getting weight to bit like they think they're getting weight to bit, right? Stacking weight up. If it's not getting there, what good are they doing? So there's Gore right now is going after that, along with, you know, you could say PWD. That's nothing new. We are bringing PWD to market, but our big push right now is to bring these drilling dynamics real time.
I think when we were drilling mostly vertical wells, weight on bit was probably a pretty reliable measurement. And I think as soon as people start seeing real time weight on bit consistently across many rigs, they will realize what a garbage measurement that is when you're in the lateral.
Oh yeah, I mean it's best. It's a not close approximation, if anything, right?
I mean, how could you possibly? I mean, you think you're trying to. I mean, really, what you want to know is how hard is the BHA pressing on the rock face, right? That's and right. You get a strain gauge right above the bit, and it'll tell you, right? But like, you know, when you just pick the string up off bottom, which it really isn't off bottom because it's, you know, a couple feet from the rock face you're breaking up, but it's still tons of it is laying on the ground, right?
Yes.
And then,
Yes.
and then zero it out there, and then you push back against the rock face, and not only do you have gravity dragging the string and causing all sorts of other issues, and it's coiling up on itself or whatever else. Like, I'm sure it's gonna be night and day different when you see that data. I'm sure it'll be shockingly helpful and what's the word I'm looking for? I'm really struggling here.
Informative.
Informative, right? Like oh my God, we really need to do something different here, right?
That's right.
And I can't wait for that kind of stuff. And that's going to be a key element of closed loop drilling. Well, is being able to to measure those variables, right?
Right.
So,
Yeah.
Well, good.
Awesome.
Thank you, Hunter. Great to have you.
Thanks, guys.
Well, that's all the time we have for today. Thanks again, Hunter, for joining us. And be sure to check out our podcast on iTunes, Spotify, and YouTube. Be sure to review and subscribe. Thanks for tuning in to today's episode.